Exponents and scientific notation. I want to look at rules of exponents. If I had a base like a raised to an exponent like m, I could think of maybe an example of 2 cubed. And 2 cubed is 8. But what happens if I take a to the m times a to the n? Keep the same base. What I do is I add the exponents. So for example, if I had 2 cubed times 2 to the 4th, this would be 2 to the 3 plus 4, which is 2 to the what? 2 to the
2 to the 7?
7th. And this should feel intuitively correct. 2 cubed is 2 times 2 times 2. 3 of those.
Right.
2 to the 4th is
2 times 2 times 2 times 2.
so that's another 4. And
Yes.
altogether you have how many sitting there?
Should have 7.
7 2s. That's all you're doing. If I go ahead and take a look at a to the m over a to the n, then I can just subtract the exponents, and it would be a to the m minus n. So for example, if I had 2 to the 5th all over 2 to the 3rd, I would go ahead and just take 2 to the 5 minus 3 and subtract the exponents, giving me what? Giving me 2
Squared?
squared. So imagine, use your imagination, you have 5 2's multiplied in the numerator. You have how many 2's multiplied in the denominator?
3.
So 3 of the 2's upstairs and downstairs would cancel, leaving, I'm trying to give you a hint, but how many 2's?
2.
All right. Then I can go ahead and take a to the m and raise it to the n. And when you raise an exponent to an exponent, you multiply them. And what would this look like? 2 to the 5th, and I would like to raise it to the 3rd power. So this would be the same as 2 to the what? 2 to the
5 times 3?
which is 2 to the what? 2 to the
2 to the 15th.
15th. See if I can verbalize this without writing it. I have 2 multiplied to itself how many times?
5 times.
5 times. Now how many groups of these do I have?
3 groups.
3 groups of 5 2's is how many 2's?
15.
Bravo. And then finally, a to the 0 is 1, and a to the negative n is 1 over a to the n. Now, once we get past rules of exponents, we want to look at things like scientific notation. So that's a number in the form of a times 10 to the n, where a is a number between 1 and 10 to include 1, not include 10. It's just the absolute value of whatever number this is, the positive value of it. And n, well, that's going to be some integer. That's going to be an integer, so it's from the numbers ... -2, -1, 0, 1, 2, ... These are the allowable exponents on the 10. Now, why is scientific notation used? To put large or small numbers in a relative context for us. If you go ahead and take a look at the 2 numbers up there, and I said, quick, which is larger? You'd be thinking, well, gee, let me count up the zeros. Whoa.
All right.
But with scientific notation, if I go ahead and just convert each of these numbers to scientific notation, I'd be able to tell quickly which is larger. So how do you convert to scientific notation? What this notation means here is that I go ahead and grab 1.23, because 1, 2, 3, I'm going to now rewrite it so that I have a number between 1 and 10 to include the 1. So I go 1 decimal place past the first non-zero digit, and then write out the rest of the non-zero digits. Then I multiply by 10, and I raise it to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 to the 11th. That's the first number that I see. Second number that I see. Well, for the second number that I see, I'm going to go ahead and do the same thing. I'm going to place the decimal point right after the first non-zero digit. That'd be right here, wouldn't it?
Yes.
So I would write what? I'd write 3.2,
2.
and then you're going to have to count with me. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the what? Times 10 to the
To the 10th.
10th. So if I'm multiplying 1.23 times 10 to the 11th versus 3.2 times 10 to the 10th, now I can quickly answer which number is larger by just looking at the exponents. And which number would be larger, actually?
The
first one.
The first one, that one right there, right? Because you're looking right here at that 11 being greater than 10. Well, that's with numbers that are larger than 1. For numbers that are smaller than 1, we can convert to scientific notation too. If I said which of these two numbers is larger, same conundrum. I think that's a word, conundrum. Same conundrum. But I do the same thing. I go to the first non-zero digit. I put a decimal point right about here. So I'll write 1.21. And then I'll multiply by 10 to the negative. Negative what? Negative?
3.
I have to come out to say 0, 1, 2. So I got 1, 0, 2, 0, 3 zeros, and then the 1. 10 to the negative
4.
4. Let's look at the second number. The second number, I'm going to again place my decimal point where? Between what two numbers?
9 and 6.
9 and 6. So I would have 9.6 times 10 to the negative. And I count over to that space past the 9. And how many spots do I count? 1, 2, 3, 4. I want to say what?
5.
5. So when your numbers are less than 1, you're using negative exponents on the 10. Which number is larger? Well, again, it's the first one because you're thinking 10 to the negative 4. That's going to be a larger number than 10 to the negative 5 because that would be 0.0001 versus 0.00001. Let's go backwards. I have a number and I want to write it in scientific notation. Now, 42,000 is a special number because that's the number of ounces that the largest pumpkin ever grown was. And that comes to 2,625 pounds. That's the largest pumpkin that was ever grown. I want to convert that number, 42,000, to scientific notation. So I'm going to go ahead and place my what? Place my decimal point here. And I'll write what? I'll write
4.2
good. And I'll multiply by 10 to the
4.
to the 4th. Very good. Let's go backwards. 9.3 times 10 to the 7th is a special number because that in miles is the distance from the Earth to the Sun. If I want to write this in scientific notation, I would write 9.3, but then I'd move the decimal point, and I would never give you a hint, but if I did, I'd do something like that. I'd move the decimal point how many times?
7.
7 times. Very good. So let's do that. Let's go ahead and move this decimal point. 1, 2, 3, 4, 5, 6, 7. And you end up with the number what? You end up with the number. Let's see if we can go ahead and switch to pen mode now. Here and here would be commas. I want to say you end up with 93 million. And we've switched from standard notation, or from scientific notation, to standard notation. And that's the distance from the Earth to the Sun, 93 million miles. Just what you thought it was. Thank you.